and welcome back to Microsoft Virtualization for VMware Professionals. In this module, we're going to be covering high availability and resiliency, some of the key features to ensure that your virtualization infrastructure stays online, stays mobile, stays dynamic. I'm Simon Perryman, Microsoft Technical Evangelist and VMware Certified Professional, and I'm joined again by Matt, a Technical Product Manager and also a VMware Certified Professional. What are we going to be covering in this module?
So in this module, up to now we've talked about density, performance, scale, loads of cool features and functionality, network virtualization. But what we haven't talked about is what happens if things go wrong.
We're using Windows Server. Nothing will ever go wrong, right?
We have to at least let people know.
We got to plan. That's the best way.
You know,
right?
if people are vacuuming and they pull the plugs out of the servers, we're going to.
I've heard of that one before. I've heard of that one.
Yeah, I'm sorry about that. But we need to provide how we can provide resiliency for that very situation. You know, that vacuuming situation. We need to provide and ensure that workloads can be as continuously available and up as they can be. So there's lots of technology and features within Windows Server 2012 and Hyper-V Server 2012 that can enable that. So should we dive in?
Let's do it.
So as part of, to set the context again, this is the fourth module before we have a meal break. We're going to focus on HA, resiliency, protection, and so on before we look in the afternoon at System Center. So resiliency, and we're going to clustering, and Simon's going to dust off his demo tools and give us a run through clustering as well, which I am thoroughly looking forward to. So let's crack on with the resiliency side of things. Now, in Windows Server 2008 R2, there was a backup capability. Windows Server Backup took full backups of virtual machines, which meant you could consume quite a lot of disk space, and it perhaps wasn't as granular as it needed to be. Things have been significantly improved in Windows Server 2012 to enable an incremental, agentless backup, which backs up quickly, efficiently, saves disk space, and it's in the box. So it's great for small organizations, small businesses. And it's also been enhanced by able to be protect to Windows Azure as well. So you can use that as a repository to back up VMs, perhaps for your long-term storage instead of maybe tape. But as I said, the new backup technology within Windows Server 2012 that's built in enables you to back up virtual machines. It backs up your Hyper-V environment, no agents required, and it's saving that network bandwidth, keeping the backup sizes small. And you can see we've got a little breakdown here. You know, on the Sunday, we're doing a full backup after enabling incremental backup, and then Monday, Tuesday, we're doing incremental backups, and Friday we decide to go back to Tuesday's backup. So we can restore, even though there are multiple differencing disks and multiple incremental backups, we can be granular about how we are backing up and restoring our key files and folders. Would this replace a more comprehensive backup solution like that of Data Protection Manager or some of our partner solutions that provide a more scaled, centralized backup solution? Probably not. But this is a big step forward for those smaller organizations who want to back up their 4 or 5 VMs on their single or 2 hosts and perhaps back those up to Windows Azure as well. So, great option. And there is a little bit about the Azure Backup. So we've got our on-premise Windows Server 2012, backing up stuff. And it's a simple download, a file you download, you run it on your server, connect it up to your subscription in Azure, and off you go. So the engine is extensible, so people can plug in the same way that Azure is plugged in. You sign up. Unfortunately, there is some billing involved. It's not free. We can't help that, unfortunately. But what it's going to do is enable you to have that long-term storage for backups for your key workloads, your applications, and so on. So we're effectively just giving you that third place or the second place if you're using disk and then instead of tape.
Now, when you back up to the cloud, Windows Azure is Microsoft's public cloud offering. Again, easy to sign up, but of course we bill for utilization. One thing to keep in mind is that it's probably going to be better than any local backup solution you have because Windows Azure is geo-replicated. And so what that means is while we will upload it to one site, the site that's closest to you, we'll actually go and back it up into multiple, at least 2 other locations, somewhere else around the world. So even if you lose that server that it's on, even if you lose that rack, even if you lose that data center, we will still have a copy of your data available for you somewhere else around the world. So you can always have confidence that you can recover it when you need it.
Exactly, and that's the beauty of it. But we realise, and we have to be, well, we don't necessarily have to be impartial, but there are other vendors who supply public cloud solutions. And the fact that the Windows Server 2012 backup capability is extensible, it means that you could plug into third-party online backup services, of which I'm sure there are a couple available already and more as we come down in the pipe. But obviously we want to talk about Azure as a great platform for you to choose for your archival long-term storage outside, off-premise, if you will, as well. So that was a little bit about backup. But what happens if we go way beyond the situation where we've pulled the plugs to do the vacuuming and we lose a site?
So disaster recovery now, not just
disaster, startling. Yeah, we're not talking about recovery just yet. We're talking a disaster. How can we provide capability in the box for that kind of scenario? Some of the key blockers around DR, about why people don't adopt: cost. It's too expensive. Replication's expensive. I need lots of infrastructure components. I need certain network connectivity of a certain speed that costs me a lot of money. Cost is one thing. Complexity. I'm a small organization. I don't necessarily have all of the advanced skills to configure a comprehensive DR solution with some of these other vendors. That cost and complexities means that, you know what, DR is just too much of a stretch for me. I'll just rely on backup, and if things go bad, then hopefully I can restore. Inflexibility. Do I need to match up stuff all over the place? Do I need to have same storage vendor technology on both sites if I'm doing storage replication? That's going to be expensive. Do I need to have certain hardware models, network switches, and so on? All of this stuff is things that people have to consider and more when they're thinking about DR. But with Hyper-V Replica and what we've built into Windows Server 2012, we're providing some of the core capability you need to provide a low-cost, simplified DR solution. And I wanted to take you through very quickly, A, how you set it up, and B, the kind of things we can do as part of that. And we'll compare and contrast it with some of the VMware replication technologies as well. So let's duck into a demo. You'll notice we've just come back to the demo environment where demo 07 has finished moving, and it's now somewhere, where did I put it? There we go, demo 7. In fact, it should just be running. Yeah, there we go, running. Just need a quick refresh. So it's been there. Didn't take very long to migrate. But anyway, I want to move out of this environment, and I want to move to my cluster. What I'm going to set up here, let's imagine the scenario where Symon, service provider, he's got one host off-site that he's kindly said I can replicate my stuff to. And I've got my on-premise infrastructure, a cluster here for local resiliency, and Simon's going to talk about clustering in a bit more detail shortly. I'm going to select Demo 3, and I've said, I spoke to Symon, we've got an agreement, can I replicate this to your infrastructure? I'm going to right-click. Now, I've already enabled Hyper-V Replica from an infrastructure perspective here. So I've turned it on my hosts. I've configured something called the Replica Broker, which is important to configure when you want to use Hyper-V Replica with a cluster. If it was just a standalone host, then I would just enable Hyper-V Replica on that host. But because these hosts are clustered, I have to do some stuff with the Hyper-V Replica Broker as well. And that's just another service that's running on the cluster that easy to configure, is all documented on TechNet as well. So I'm going to select Demo 3. I'm going to right-click, Replication, enable replication. And I'm going to choose where I want to replicate. And Simon's kindly given me the address. Now, it could be part of my domain, but it could be somewhere different. I could be replicating across the internet, so I might want to use certificates over a certain port. As long as I can see that target, and some of that is involved obviously in the general connectivity between yours and the target location site, then I can send it via replica. So I'm going to click replica server. Yep, it's that one. It's on my network in this case for convenience. I'm going to compress the data, and I can't tweak that and tune that at this point. It's just going to compress, and you'll see savings there. We'll go next. This virtual machine could have lots of disks. It could have a separate virtual hard disk for page file. It could have a separate virtual hard disk for something else. I don't have to replicate all of them. I can choose which ones are important to me. The OS drive is probably one I would recommend you replicating, because when it gets to the other side, you're not going to be able to start a VM that's just got a data VHD attached to it. It's going to be largely pointless. So I'm going to choose this one. Recovery history. Do I want to just keep the latest recovery point? And bear in mind, Hyper-V Replica is sending the delta changes every 15 minutes, just the changes. In fact, every 5 minutes, every couple of minutes, just the delta changes from site A to site B, asynchronously. So over commercial broadband links. We're not designing this to require things like dark fiber between your sites, because that's not realistic for customers of all shapes and sizes. So I can choose, do I want the latest recovery point, or do I want to get a bit more granular? And I think I can have up to 16, I know 15 in this case, and the latest. And that's going to consume additional disk space based on the churn of that virtual machine. And I can also integrate with VSS. So it will take application consistent copies of the VM as opposed to crash consistent. I'm going to take the latest recovery point. We'll go next. Now, how do I want to get that initial data over the wire? Do I want to send it via the network now? Now, obviously, we're on a LAN environment in this demo environment, so it's going to be gigabit, it's going to be quick and useful for demos. But if I'm at the end of a really slow broadband link that I wouldn't want to send 13 gig of data because it's just going to take too long, I could copy that to media and ship it, send it over, take it over on USB media and import it into the target environment and then start replicating the bits that have changed. Or I can use an existing machine that may already exist on that site that's maybe a backup that you've restored to the replica server, and I can start replicating onto that as well. I can start it now or later as well, so I've got a bit of flexibility there. We'll go next, and we'll go finish. And fingers crossed, there we go. So if I bring this up slightly here, sending initial replica right at the bottom here. So it's sending that across the wire. Now, obviously, this is going fast because it's on the LAN. 13 gig of data over gigabit isn't going to take that long. But just to give you the idea, primary server where it's running, my site. Where it's been sent to is Symon's Hyper-V server that he's kindly lent me, but is probably going to charge me an arm and a leg when I finish with it. Let's pop over to Symon's site now and see what's being received. So let's pretend that this is Symon's machine here. And you'll see demo 3 is already coming in. Replication, it's coming over. We're not quite finished yet. It's pending the initial replication, hence the warning. So the health is not quite there yet, and we're receiving changes. But this particular one here, demo 4, is one I made earlier, if you will. And that's, you just saw it pop up there, receiving changes. So that's just a couple of deltas that have been sent across. There's not a massive amount of churn in these VMs because they're pretty much sat idle. So if I look at the summary, in fact, if I look at right-click and replication and view replication health, everything's pretty good. Successful replication cycles, 175 out of 175, so we're all good, and the last synchronization was just minutes ago. Great so far. What happens if things aren't going to plan and I want to fail over? Well, let's say for argument's sake, I've just had a phone call, there's an impending disaster on the way, maybe a weather front is coming in, a storm, some other planned, or not planned disaster, but something we've been given early warning of. I've got the ability now to say, okay, we're just out of business hours on the Friday, the storm's going to hit over the weekend, it's going to affect my area and could have a power outage in my data center. So what I'm going to do is I'm going to shut down cleanly my workload. So that goes down relatively quickly, there we go. I'm going to right click and I'm going to do what's known as a planned failover because I've been told about the impending situation, I've got time, I'm going to plan this, and I'm going to start it when it's failed over. And that's going to migrate to Symon's site. Unfortunately, Symon's site is in a completely different geography in the US, for argument's sake. And in that case, he's not going to be impacted by this impending weather front or whatever it may be. So we'll go failover, and you'll see, yeah, sent the delta changes that have changed since the last replication. And we got a nice message that says it's been successfully started on the other destination or the target. So we'll close that. Still off here. We'll go to Symon's infrastructure. And demo 4 is still running and it's been running for 11 seconds now. It doesn't get much more simple than that. For an SMB customer, for a mid-market, even for an enterprise with remote branch offices that are connecting back into the main site, simple to configure, can be automated through PowerShell, which means if I've got 10 VMs I want to move, 100, 1,000, a script would allow me to do that.
Great. That was actually the next question that I wanted to ask you. What levels of automation do we have? And so through scripting, this is how we provide automation. Is that right?
Exactly. And the Hyper-V Replica commandlets, they're all published on TechNet. You saw the commandlets for resource metering. With a little bit of work and a little bit of investment in time, even if you're not a PowerShell guru, I could very easily build a script that ran through my list of virtual machines, check if Replica is enabled. If so, has the replica been successful? Yes. Shut down VM, failover, move to next VM. While one is less than 10, do this. That kind of stuff. You could build a very easy scripted solution in PowerShell that you could just run in the event of that situation requiring some kind of intervention. It's less likely that organizations who have DR solutions want that failover to be automated completely with no interaction. What I mean there is, what if it's a false positive? What if you're using some kind of alerting system that if this alert fires, this kicks in? An ops manager alert or a third-party alert that says, oh, we've detected something, you need to go into failover mode, and everything shifts to the entire second site. and yet it was a false positive and we didn't need to do that. There's been unnecessary downtime as a result. So having that automation for the actual migration bit, but having it triggered by a human, is in some cases more appropriate for some organizations.
Right, and just to add to that, there is a System Center product called System Center Orchestrator, which allows us to build automated workflows, and we can certainly integrate in there through PowerShell scripts and other mechanisms. Now, you kind of touched on one point that I want to elaborate on as well. You know, a lot of our customers out here, they only have a single data center, right? They're a single location, yet they still want to have this disaster recovery option available. Well, we're actually seeing a lot of third parties, service providers that are offering their own data center as essentially a disaster recovery site. So if you're working with a single data center right now, don't think, oh, I can't use this replication feature for a potentially big problem. Go search with your local service providers, or even a service provider that's on the other side of the country, and consider using them as this replication backup site so that you can have that resiliency. So a lot of flexibility, a lot of options with our partners out there.
And that's a good point. And the beauty of this solution is, with it being asynchronous and with it being at the Hyper-V layer, if I'm replicating from my site and I'm running, for argument's sake, Dell hardware, and you've got HP, IBM, whoever, and I've got some storage subsystem from one vendor and you've got a different one, and I'm using certain network technology and you're using different. It just doesn't matter. So I can migrate, because it's not live, I can migrate to a completely different infrastructure across the other side of the country or the world, and they could have a completely different fabric and infrastructure, and it will just work. So it overcomes many of those inflexibilities around delivering a DR. It's in the box, so it's low cost. There's no extra per VM charge associated with Hyper-V Replica. It's simple to configure, as you saw, can be automated through PowerShell. But some of the other things that I just want to touch on so you're aware. What if I was moving from my site, 192.168.whatever networking, to Symon's site, and he's on 10.10.whatever networks, and we aren't using network virtualization? How can we account for, when I move over in the event of a pending disaster, or in the event of a disaster, that the IP address situation sorts itself out? Well, if I look at the settings of Con Demo 3 here, one of the VMs that's been replicated, and I look at the network adapter, when I expand, you'll see I've got an extra setting here that we didn't have before. In fact, I've got an extra couple of settings. The first one is Failover TCP/IP. So in advance of this problem happening, or this potential problem happening, I can say, you know what, I know when I'm going to fail over that these VMs are going to have to jump from a 192.168.2.10 or whatever network to a 10.10.10. whatever. So I can enter that information in here. The new default gateway, the DNS server, so that when my workloads do come up in that second site, that they're ready to go as quickly as possible. The last thing you want to be doing with 20 VMs as a small organization, 50, 100, whatever, when they're all failing over, is going through each individual one and updating all of the network settings to make sure this all works. When you're panicked and rushed and you are then the bottleneck, you want to be able to do it in advance when you've got time and you're comfortable. The other area is testing failover. So if I'm a small organization or a large enterprise, remote sites, and I want to make sure I understand what's going to happen in the event of a failover, what's the impact going to be, how is the workload going to work, then I can right-click Replication and test failover. So I can bring that workload up in the second site in an isolated network environment, the configuration options we briefly saw a minute ago, bring that up, and it enables me to test what's going on, the interaction between VMs, the settings, can I reach it, and so on. So these are two very useful capabilities that are built into Hyper-V Replica from a granularity perspective. Now you'll notice actually one difference. When I clicked here before, in fact if I shut this VM down, this is the running side, I shut this VM down and right-click Replication. I've got this option of planned failover. That's because I'm currently on the primary VM. However, if I'd lost the primary site, so I've lost the cluster and I'm just relying now on the VM that's been replicated to the secondary, so I'm right-clicked on a VM on the secondary site, you'll notice I've got failover. I've not got planned failover because I've lost the first site. I've just got failover. And what that's doing is basically saying, okay, we've lost everything on the first site, we need to bring up your second site. And I'll just click there and go through the wizard and it will start it up. So that assumes that you've lost the main site. It's gone. You didn't fail things over in a planned manner because maybe it was a disaster you didn't expect or know about. So that's just some of the granularity within Hyper-V Replica. And I think it's an incredibly powerful solution. Symon highlighted almost DR as a service, if you will. You know, service providers, small and partners, big and small, offering their capacity and resource usage that may be spare to offer small and mid-sized organizations a solution for DR. But also large enterprises can harness this technology from their branches to their central sites and between their data centers as well.
So I got one really good question here. The question is, hey, I have a very small network, not a lot of I/O goes through it. Can I effectively use Hyper-V Replica? And so for that you can. We don't place any limitations on the replication. And what we actually do is change-based replication. So the very first time we take a look at the replica, we back up the entire VHD. And that could be a lot of data. But every subsequent time, we only keep track of the changes and only back up those changes. So there's actually minimal amount of traffic that we're passing over the second, the third, subsequent times. But also with that initial backup, you actually have the option to do the backup onto physical media. So if you're copying or replicating a 10 gigabyte VHD file, go put it on a thumb drive, take it to your backup site, load it there. And after that point, then do the change-based replication. So you have a few options with how you can configure this. And really, you shouldn't have to worry about slow networks. Though, of course, faster the networks, better resiliency you're going to have.
Yeah, and just to provide a little bit more detail about Replica, just some of the key things you need to consider as well. If we're looking here on the slide, you've got things like automatic handling of live migration. Why is that important? Well, think where I did my planned failover from. That VM was part of a cluster. So that VM could have been migrated around that cluster at any point in time. Hyper-V Replica is aware of that, which means that if I move that VM from node A to node B and then to node C, it's not going to stop the replication. It's just going to carry on as normal. It understands all that. It's completely live migration aware. And one other key area is down here with the send and receive replica traffic. Because once I did that planned failover from cluster to Symon's infrastructure, it automatically started replicating back the other way. So that if I did want to fail over back the other way, the data is always up to date. So it's giving me that simplified administration, but with powerful capabilities under the cover. And what you can see here in this example, we've got the primary site where you've got 2 physical servers with an SMB file share as that central location for your VMs. All the Hyper-V role and tools with the commandlets and UI. We've replicated over, and in the event of a failover, we're actually replicating to 3 physical servers with a SAN. So rather than SMB storage, we're actually using either Fibre Channel or iSCSI storage in this case. Complete flexibility. There's no need for any other replication technology. Gives you a lot of granularity and a lot of power. So the final area I want to quickly talk about was and demonstrate was an area that I think probably caused quite a significant amount of feedback based on the previous wave of Windows Server and Hyper-V technology. And that was around NIC teaming. So in 2008 and R2, as organizations were embracing Hyper-V more and more, they were using NIC teaming software from third parties like Broadcom, Intel, HP, to team their physical NICs, so aggregate the physical network adapters together, so that when you created a Hyper-V virtual switch and used VMs through that team, you would get more resiliency and throughput and performance. But sometimes the interaction between the team and the Hyper-V vSwitch wasn't ideal, and the supportability of the solution sometimes was a little bit confusing. Do I go to the NIC vendor? Do I go to Microsoft? If there's a problem, do we have to dissolve the team and figure out what's gone on and then assume whether it's the team that was causing the problem or not? There was lots of complexity. We've simplified it because we've taken the network teaming in-house. So now it's all part of Windows Server 2012. And I want to show you how easy and how flexible it is to team the network adapters in Windows Server 2012. So let's pop into our little demo environment here. There we go. And I'm actually going to choose this particular VM. I'm going to open up Server Manager. Because this virtual machine that I've got here has got 2 NICs. So I'm going to click on configure this local server. So remember, this is inside a VM. This could be a physical server. The process is exactly the same. And you'll see that under here, NIC teaming, disabled. Now again, I could do this through PowerShell. So don't forget, PowerShell for everything if you want. I'm going to click on disabled. Move this little interface so we can see it a bit more. There we go. And you'll see I've got 2 NICs. So remember, this is a VM, so I've created the VM with 2 virtual NICs. So, but again, the process will be the same. I've got the server itself, it's online, everything's good. No teams. Tasks. New team. Side team. There we go. Which NICs? tick, tick. Any additional properties? So some of these will not be available depending on whether or not I have whether it's in a physical world or not. But I can choose if I want a standby adapter or all active. These are grayed out because I don't have them available to me in the VM. But if I'm using switch dependent or independent teaming, and I can change the load balancing mode as well. But I'm going to leave them as they are. Click OK. Here we go, configuring. Bang, there we go, done. And if I want to dissolve that, tasks, delete team, or in fact I can change the properties and add more NICs to the team if I'd added more physical NICs at that point, or within Windows Server. So it makes it so flexible, it's so easy, and it makes sense, and it's supported right through the stack now. But in terms of flexibility, which we talked about earlier, you can't get more flexible than being able to team any network card from any vendor up to 32 NICs in a team. That's pretty flexible, I'd say. So mixed teams, gigabit NICs from Broadcom, HP, whoever they may be, Intel, you insert network vendor here, team them together, and you're good to go. We manage and we handle all of that process. It's probably not best to mix teams of different speeds. That could result in some different results, but team the NICs of similar, and more than likely you'll have similar NICs within the servers performing similar services. So if you've got two 10 gig NICs that you want to give to VMs, team them together in that way. Just something to be aware of. But that's easy, really straightforward, and just means that as an administrator, it's so easy and just and I could be reassured that I'm providing an aggregated, increased throughput, resiliency, and it's supported by Microsoft as well. So I know who I need to call should I have a problem, right through the stack. So it's about time that Simon dusted off his keyboard. Yeah, a bit more. Dusted off his mouse, and we start to look at clustering, because we talked a lot about clustering up to now. I've used it for the live migrations. We've alluded to some of the stuff it can do and why we need it. But I'm going to let Simon demo and talk through a bit more detail, go back to his roots, and really show us and elaborate just why clustering is so powerful and what it can do in Windows Server 2012. So I'll hand over to Simon for this one.
All right, thanks, Matt. So I'm going to launch my demo system here. And what I have are 3 physical servers, physical hosts, and I've pre-configured them with my iSCSI storage. So what you'll see here on the screen is my iSCSI initiator, just showing that it's connected. And I've already connected this to Node 2 and to Node 3. So what's going to happen when we build the cluster? We want to find a really easy way to find your shared storage. And so what we do, we simply create a list of all of the disks that Node 1 can see, or the list that disks that Node 2 can see, or the disks that Node 3 can see. We map this list and we figure out the common set of disks. And we say, hey, you have shared storage across these 3 nodes. This is probably going to be the disk that you're going to actually use in your cluster. Now, of course, you have the ability to add disks, delete disks, relatively straightforward. So don't feel you're restricted by this initial deployment wizard. But what we essentially worked on with clustering was simplification. Now, if you did clustering in 2003 or in the past, it was really painful to get up and running. You had a 50-page white paper, you had a detailed list of hardware compatibility, and every single component that you wanted in your cluster had to be on this list. And so it led to a lot of problems when people wanted to upgrade their clusters after a few years, or maybe they just wanted to add a new node sometime later. If it wasn't on this supported list, no good. And so that caused a lot of pain. What we decided to do since Server 2008 was simplify the support matrix. There's now just 2 requirements for your hardware in the cluster. Every component must be logoed, so Windows Server logo, and the entire solution must pass our best practice analyzer. And we call this validate. And I'm going to jump in here, and I'm actually going to walk you through cluster validation so you can see what we're really doing. Now, essentially, our goal here with cluster validation is to ensure that your cluster will work before you actually get it up and running and start deploying workloads on it. So what it's going to do is it's going to ask me what nodes are going to be in your cluster. So I'm going to go specify my 3 cluster nodes, number 1, number 2, and number 3. And I'm going to click Add. And what's going to happen now is that the Failover Cluster Manager is going to look at each node and ensure that the failover clustering feature has been enabled. In this case, it has. Next thing it's going to do is ask me, do I want to run all of the tests or just a subset of tests? Now, for the sake of time, I'm going to select a subset of tests. But to be officially supported, running in production, you want to make sure that you run all of your tests. Now, this just ensures that we're really testing every part of the solution. When we look at our system configuration, we check that you have things such as the correct operating system installed, the correct service pack, consistent patches. When we look at our storage, we're going to check that the disks can see each other, that the disks can fail over between each nodes, and that they support a key requirement that we have here called persistent reservations. Now, if you've purchased storage in the last decade, it has persistent reservations, not to worry. But we'll ensure this and check this as part of these tests. Next, we're going to look at the networking tests. We're going to check the IP configuration, make sure that the nodes can communicate with each other, and we're also going to check for some best practices, such as making sure that you have at least 2 networking interfaces. We're then going to take a look at the inventory, which gives details about the storage and the system and how that's configured. And so what you're going to find this useful for is anytime you have a product support question and you need to call up, rather than run these additional tools, rather than describe how your cluster is deployed, simply send them this validation report. It's a detailed list of how every component is configured and run. And additionally, a lot of people have these compliance or legal requirements where they have to inventory every single part of their cluster, of their servers. And often we see clusters used for these mission-critical workloads, and so having this easy-to-inventory method benefits a lot of our customers. But let's disable our inventory, network, storage, and system configuration tests, and just run our Hyper-V tests. And what these Hyper-V tests do is, if we notice that the Hyper-V role is installed on at least one node, we're going to go run these tests because we think that you might be creating a Hyper-V cluster. So I'm going to say View Report. And what this is going to do is launch this report that I've just created. I'm going to zoom out a little, and you can see that it goes through these tests. Now, here's the Hyper-V one that I've just run here. So we get information about the servers that are running Hyper-V. We get information about their storage, their resource pools, their virtual switches, their processors, whether the role is installed, whether they have consistent processor manufacturers. And so we recommend this because we assume you want to use live migration. When you're using live migration, you need to have all Intel or all AMD. But if you take a look at some other reports, these are some that I ran earlier, you can actually see that they have different warnings, different metrics for success. Now, to have a fully supported cluster, warnings are okay, success is what you need. But if you have any of these failed tests, technically you're not going to be supported. Now, essentially a warning says you're not following a best practice, but it will work. An error means, hey, we have a real problem. Now, for example, this error is telling me that I have some corrupt data on my disk. So it's really important, really useful that it's telling me about this disk before I add it to my cluster and try to use it in production because, you know what, this disk, it's not going to work effectively. So we're telling you up front, hey, go fix this disk before you add it to the cluster. This way you can ensure that it works as expected and you get high availability. Now, creating a cluster is extremely easy. It's literally a few steps. Step 1, what nodes do you want in your cluster? Step 2, provide a name for the cluster. Go. It really is that easy. Now, if you're using DHCP, we don't even ask you for an IP address. We will go contact the DHCP server, find a free IP address, use that. If you want to use static IP addresses, we'll actually prompt you for a new static IP address. So in this case, let's go and name my cluster. We're going to call this Sci Cluster VMware in honor of our excellent jump start here. Now, we have the option to add all eligible storage to the cluster. We'll go ahead and do that. And what it's going to do, again, is look at the storage which can be consistently seen across all of my nodes. And it really is that simple to create a cluster. Name the nodes, give the cluster a name, go. We handle everything else for you. So what's going to happen now is we're now creating the objects in Active Directory. Now, I saw a few questions come in earlier asking, is Active Directory required for clustering? The answer to that is yes, it is. So whenever we're creating new cluster objects, that's when we want to be using Active Directory. This ensures that for these mission-critical applications, we have proper admins in our environment that are managing all of these objects. Now, in our old version of clustering, Windows Server 2008 R2, one challenge that a lot of customers had was they would virtualize their entire infrastructure, including their domain controllers. And clustering back then required access to Active Directory just to start a virtual machine, or the cluster. So if you had a big crash, you lost all of your VMs, we had kind of a chicken and egg situation. You couldn't start your VM, which had your domain controller, because the cluster needed access to a domain controller, and so you couldn't start the cluster. So there's a long workaround to get out of that, but we heard that as great customer feedback to eliminate this restriction on Active Directory for day-to-day operations. So for regular clustering, you don't need access to Active Directory to start your cluster, to start VMs, things like that. It's just when you're creating new cluster objects, that's when we need access to Active Directory. Now we can see back to my demo that the cluster has been created. Took about a minute. And we actually have a report as well. So anything we do with a cluster, we automatically generate a report, and we're going to save all of these reports for you you've ever done on this cluster on every node in a C Windows cluster report folder. So if you need to refer back to what that old admin did before you took the job, you have all of this data right in front of you. So let's jump back to the cluster. Click Finish. We're going to go see this new cluster that I just created get loaded. Now, Matt gave us a kind of a brief tour here where we talked about the different roles we have, the different nodes, here's my 3 nodes, the different storage, and our different networks. Now, I'm going to give you guys a real quick quiz, okay? Looking at what you see here, what best practice am I not following with my cluster? So if we could switch back to the view, you guys type it out, what best practice am I not following? I'll answer that one in about 30 seconds, because now I'm going to talk a little more about networking best practices. Now, when you think about deploying a cluster network, one of the things you need to think about is what type of traffic is going through each network. Now, if you're using a 10 gig E network, really thick pipe, you probably set all types of traffic through there without having it interfere with each other too much. But let's say you have a 100 megabyte network. Well, you have to be careful of flooding that network, saturating it with, let's say, a live migration traffic, because you want other communication to still be able to go through. Now, the way the cluster nodes check the health of each other, they're basically pinging each other. These are called our heartbeats or our health checks. Now, think about if you have just a network that's entirely flooded by live migration traffic. Those pings between the nodes, they may get blocked. That traffic may not get through, and so one cluster node may think another one is down. So best practice for networks is to separate their usage or separate their traffic by the different use. So best practice is to have one network for your cluster management. So this is things such as deploying virtual machines to my cluster, access to my cluster administration pane, things like that. We're going to want to have a dedicated network for my live migration traffic. When we do a live migration, this floods, saturates the network. So we want to make sure that we're not impacting anything else. We want to have a network for all of our cluster communication. So this is when a cluster makes an update, it broadcasts the update to the other nodes in the cluster. This is the cluster health checks that are going back and forth with each other. By isolating this, we can ensure that the cluster communication always goes through and is never blocked. And then we're going to want to have an isolated network for our application or our public traffic. So for example, let's say I have a website that's running on a VM. Well, we need the public to be able to access that website, so we still need to offer them a public-facing network. And we want to be resilient to, let's say, a denial of service attack, where someone floods the network and causes a lot of network interference, because we don't want that to block our cluster communication, trigger a false failover. So we always want to try to separate these roles. So to answer the question, the best practice I'm not following here, I only have one network, so shame on me. I should have at least 2 for redundancy, and for a Hyper-V cluster, probably want to get up to 4. Now, some other considerations with networking. If you're using an Ethernet-based storage protocol, such as iSCSI or Fiber Channel over Ethernet, you're going to want to have a dedicated network to that storage array as well, so that we don't block any storage I/O. If you're doing regular backups, a best practice might be to have a dedicated network for backup / Hyper-V Replica. Ultimately, that will depend on the frequency of your backups, amount of data. Now, let me switch back to some storage here. Now, under storage, as I mentioned, we look at all of the nodes, and we figure out which disks are available across all of my nodes. And in this case, I found 3 20 gigabyte LUNs. And again, all of this is attached through iSCSI. Now, what I'm going to do here is I am going to convert these to what we call cluster shared volume disks, or CSV. This is functionally equivalent to VMFS, a clustered file system. There's a few technicalities why this isn't a clustered file system. There's no distributed log manager. But as far as conceptually, you can assume that this is a distributed access file system that's been optimized for Hyper-V. Now, what this means is essentially all of the nodes can simultaneously write to a LUN at the same time. So this means that we can spread out our virtual machines across different nodes, and they're all accessing a single disk from those different virtual machines. So converting one of these disks, pretty tricky. You have to, first of all, select the disks, and then click this button that says Add to Cluster Shared Volumes. So crazy stuff, but everyone, I think, is able to handle this one. So it really is that easy. You know, deploying a cluster, 2 steps. Creating clustered disks, 1 step. And now what this does is, under our C file, it now will create a clustered storage folder. Now, essentially, this is it's called a repass point, but you can almost think of this as a distributed access file share here. And so what this means is, Node 1 can access the disk by C, cluster storage volume 1. Node 2 can access the same disk by C, cluster storage volume 1. So this way, we can always have a consistent file path for all of our nodes to go and access our disk. Now that we've got our clustered disks set up, let's go ahead and actually deploy a virtual machine. Now, one thing that we wanted to do with Failover Cluster Manager and distinguishing it from Hyper-V Manager that you see here is simplify things for our administrators, so you no longer need to do some things in Hyper-V Manager, do some things in Failover Cluster Manager. We really wanted to simplify and do day-to-day operations just in Failover Cluster Manager. And so we're actually launching a bunch of the Hyper-V wizards straight through Failover Cluster Manager. So first thing I'm going to do here is go create a new virtual machine. Get to select my node. And then what it's going to do is launch the Hyper-V Manager wizard for creating a new virtual machine. Now, we walked through this a little earlier, so I'm just going to go quick, but I want to point out one important difference in a sec. So Matt was kind enough to name all of his infrastructure after me, so guess what? We're now going to go for the McSpirit VMs.
Actually, I have another friend called Simon, and it was after him.
Oh, okay. Shame on me. I guess I wasn't good enough for that one.
Don't flatter yourself.
So now we got our VM McSpirit. And since we're going to use clustered storage here, we're going to go and actually put it in this CSV volume. So C, cluster storage, volume 1. Click Next. Get to configure my memory.
So just out of interest there, when you click dynamic memory, that would use, when you go back to the setting, we talked about it earlier when we were saying, would it use the whole amount of the box? And
right.
That's going to set, if you just tick that box and don't make any other changes, when you get to your VM, the maximum memory that it will automatically have set will reflect that's available in your box.
Great tip there. Now, next thing again, we get to pick our external network adapters. We can install our VHD now for our operating system, but we'll actually install the guest OS later. Click Finish. Now this finishes this wizard, and it quickly launches a second wizard here, the High Availability wizard. And this is just adding it to the cluster. So the difference between creating a VM directly on a Hyper-V host versus creating it on a cluster, you simply have to specify that you're using clustered storage. Otherwise, everything else is the same. And so if I go and click on my properties of the VM, I can click Settings, and I actually get the full list of Hyper-V settings. So here, I can look at my memory. And you can see that all my maximum memory has been assigned here, my processors, my NICs, everything like that. But now again, the big change, we're storing all of our virtual machine configuration information in C cluster storage. So let me cancel out of that. I'm going to go ahead, start up this virtual machine. Then I'm going to turn it back over to Matt. He's going to cover, I believe, cluster-aware updating. And then we'll be back to the exciting second part of the demo soon.
I've got a quick question though that relates to some of the networking. The CSV network. aside from you having isolation, what is its function? What is its sole job?
So really with the CSV network, we use that network for our internode cluster communication. So essentially your CSV network is now going to be the same network that you do your health checks on. It's going to be the same network that we basically send updates on. So when the state of a virtual machine changes on one node, it goes from online to offline. We want all the other nodes in the cluster to see that change, so we broadcast an update through our global update manager. So essentially with this CSV network, it's basically managing the access to this file system. So I'm going to spend just 1 minute giving a real brief overview of how cluster shared volumes works, because very deep topic, a lot of information. Now, cluster shared volumes, what we basically do with CSV is we allow all of the nodes to simultaneously access the disk and write at one time. But the challenge in traditional clustered disk models is that if you're writing to the same block of data, that could potentially cause corruption. So we really need to be resilient and ensure that only one owner, one VM, is writing to a particular block of data at a particular time. So when a virtual machine starts on a node, it goes through the CSV network and it speaks to a cluster shared volume service called our coordinator node. So for every CSV disk, we assign a random node to be the coordinator. And basically this does some processing to figure out when the different virtual machines can access our disk, again, to avoid that simultaneous writing. And so when our virtual machine comes online, it goes to the CSV coordinator node. It says, hi, which blocks of data are mine? So the CSV will tell it back, you have blocks 1 through 100 on the disk. So now the virtual machine, it will go and directly write blocks 1 through 100. So the only traffic that's going through that CSV network at that time is this request, information gets sent back. So we're constantly writing blocks 1 through 100. That VM does that. VM2 writes 101 through 200. And so all of these VMs are writing to separate blocks. Now, when you're working with a disk, of course, there are going to be changes to the file system that happen. We call this metadata updates. So for example, if you extend the file system, if you rename it, if you bring a disk online, bring a disk offline, this is actually changing the structure of those blocks of data and how they're laid out. So whenever we make a change to the file system, only the coordinator node's going to do that. He's going to make the changes, and while that's happening, he's going to tell all the other nodes to basically hold off their data. Don't go and push this to your old blocks because it may change. Once we change the file system, the coordinator then tells the VMs, hey, you no longer have blocks 1 through 100, you have blocks 50 through 150. Once it has this updated information, it will write directly to those blocks. This way, it's always ensuring we have a single writer to a single block of data. Now, one other thing to add about CSV is it does have resiliency as well. So let's say that access from your virtual machine to your CSV disk, you lose that storage fabric, you lose that storage interconnect, it goes offline. Well, in the traditional worlds, you would have to fail over that virtual machine to another host which had access back to the storage. What we can actually do with clustered shared volumes is called what we call redirected access. And then rather than sending it down through this path, through the storage fabric, we can actually redirect that traffic through one of our networks and then send it through a node on another network that still has access to the disk. So think about this storage being redirected from one host to another host back to the CSV disk, so that you can essentially lose a storage connection, still have no downtime to that virtual machine, and no data loss. Once that storage connection comes back up, we'll reconnect it to the VM, and the VM continues with its regular operations. I think that was kind of a long-winded answer on that, but I think that covered the basics there.
You've given me a wealth of clustering knowledge there. Thank you very much. So going back to the slides, just to kind of briefly wrap up some of the clustering bits and build on what Symon talked about and show some other stuff as well that's relating to clustering. We touched on this right at the start. We talked about clustering and scale. The clustering team have done an immense job on building a clustered system that's going to enable you to scale hugely. And we're talking in context of virtual machines here. Massive amount of scalability from a physical perspective with a lot of virtual machines running on there. there's not going to be many organizations that are going to be restricted by this, I don't believe, especially now that we can move VMs between clusters as well. So it is that boundary of local resiliency, but not a boundary of agility for moving workloads around flexibly. I don't know if you want to talk to us about some of the guest clustering. I know you were dying to tell us earlier on when we were doing virtual fiber channel, we were talking about that, and I think there's some good stuff, and we talked a little bit about it earlier on, but it might be worth just reiterating, just to clarify what people can do inside the VMs and what choices they have.
Absolutely. So with guest clustering, once again, this is providing resiliency for applications running inside a VM. So traditional host clustering, you move virtual machines around, you have failover for virtual machines. But what happens within that virtual machine? Let's say you have to patch the guest operating system. Well, you got to shut down the service, patch it, reboot, bring it back up. Hey, that's downtime. What if the service inside the virtual machine freezes or it hangs? So what the idea of guest clustering is it's connecting our different virtual machines together. These virtual machines are running Windows Server 2008, 2008 R2, 2012, any version that supports clustering. And you're essentially clustering inside the virtual layer. So let's say I have a 2-node guest cluster. I'm running SQL in my guest cluster. Well, to connect out, I got to connect my storage, so I can use fiber channel with this virtualized fiber adapter, or I can use one of the Ethernet networking protocols, such as iSCSI, fiber channel over Ethernet. So I could essentially copy, send my data outside of my VMs. So that connects them, and then we're constantly monitoring the health of each other's VMs and of the service. So if my SQL server crashes, we can restart it within that VM. If I need to patch one of my virtual machines, servicing, we can actually fail over the SQL app to the other node, do patching, fail it back, do patching. So you can actually have this high availability and resiliency within the VM. So first question I get is, can I do live migration of this application within a VM? No, you can't. We're already virtualized. We don't offer nested virtualization. So when you move this SQL database from the first node to the second node, it will be a standard failover, where we gracefully push the data to the disk, gracefully bring it back online. So yes, there will be downtime, but it'll be much shorter than if you actually had to shut down the service, apply a patch, reboot, bring it back online.
That's a SQL-specific function, though, isn't it? That's not related to Hyper-V Live migration.
That's correct. And as far as the application, I just use SQL as an example. It has, some great recent performance updates in Hyper-V. But anything that's supported on a cluster can run inside the guest. So DHCP, iSCSI, INS, DTC, MSMQ, file servers, print servers, Win servers, IIS servers, you name it. If a cluster can support it, you can cluster it within the guest operating system as well.
Yeah, so it's kind of clustering on clustering.
Exactly.
So clustering squared.
So highest availability possible. This way you get failures, and you can do this cluster on cluster so long as it passes validate. So long as, everything's logoed, pass validate, you can have resiliency for your physical infrastructure and for your virtualized infrastructure as well.
So could I have a 64-node cluster on one host?
You could, but that would be a single point of failure. And one thing that you always want to be careful of, if you have clusters on clusters, say I have a 4-node guest cluster, if I have that running on a single physical host, I lose that host, I lose my entire guest cluster. And so we've actually had a feature around for a while, which we call anti-affinity. And what anti-affinity does is it purposely spreads out virtual machines, which you tag, so that they distribute themselves across different hosts. Another great example of anti-affinity would be if you virtualize infrastructure roles. So let's say I have 2 virtualized domain controllers. Well, if I put those 2 on a single host, I lose that host, I've lost my domain controllers. So using this anti-affinity, we force these virtual machines to run on different hosts so that we only have one that fails and eliminate this single point of failure.
But it is a soft control, isn't it, in the sense that if there was nowhere else that VM could run, in the event of one of the hosts has failed, the other DC is now failing over to the same node that the current DC is on. So we have got 2 DCs on one host. it's not going to not fail it over
That's
because
correct, yeah.
of that rule. It's soft, but it's going to try its best to keep them apart.
It's soft. So exactly. Our goal is to keep your virtual machines running. It may not be optimized in this case, but hey, it's better than not having it running.
And I think we're going to look at that shortly anyway. We're going to look at the priority and stuff
That's
like
right,
that in a few slides' time. But just to wrap up this first section on clustering, so we talked about scale, guest clustering, and we'll highlight some of the key differences around guest clustering from a Hyper-V and a VMware perspective. But also, let's think about security. We touched on BitLocker now being able to encrypt clustered storage, which is useful for certain configurations and certain scenarios that customers face. But finally, and Simon's done a great job of dissecting and helping us understand what CSV is generally all about and how it works. What changed? What was the big change from 2008 R2 CSV, where it was introduced and gave us much more flexibility around VM placement, but it was still a kind of a feature that you had to enable. It didn't feel like a core part of 2008 R2 and Hyper-V. So what's changed in relation to that, and also storage arrays, replication, antivirus, that kind of stuff?
Great question. So to answer it very quickly, we completely rewrote cluster shared volumes in this
Why not?
From scratch.
Why not?
And essentially, cluster shared volumes in its initial implementation, version 1, great, functional, covered Hyper-V. But as you alluded to, we actually had some problems with integration with antivirus, with backup. The reason for this, basically the way CSV used to communicate is it would have a filter which was stuck on the file system stack. It was a file system mini filter. And so whenever we hit that filter, sometimes we would send cluster shared volume traffic across. So sometimes traffic going up the stack would go across, not go all the way up. Traffic coming down the stack would go across, not go all the way down. So when you had other applications which were dependent on the file system, they would be stuck in different locations, such as backup. Hey, we've added a new component. We now need to make sure we're backing up this file. Antivirus. Hey, you've added a new file. We need to make sure we're scanning it. And so sometimes you would actually not see these backups, not see this antivirus. So we re-engineered this in Windows Server 2012, and we've changed the way it's implemented so that we make sure that we always see the traffic. So CSV is faster, it's more resilient, and now it actually supports more than just the basic Hyper-V role. So as Matt alluded to, in the original version CSV1, you actually had to agree to an end-user license agreement to go and enable Hyper-V. And who wants to sign up? Enable CSV, right? Who wants to sign up for that and read all this stuff? But basically, what this EULA did, it said, hey, only use this for Hyper-V. If you use it for something else, it's not going to work. Don't call support. Just don't do it. So what we did with this release, we wanted to really expand support. So now we support Hyper-V over SMB. So this is using the traditional whack my share name. Sorry, whack Matt share name.
Yeah.
Playing with each other's names here. And now it also supports one of the new implementations of file servers. So with Windows Server 2012, we have a new feature called continually available file servers. And what we do is we use cluster shared volumes to provide distributed access to a disk. Now, if you think of a traditional file server, we have the file share name, which is published, right? Whack Matt share. If we needed to reboot that server, the file server, it would come offline, it would come back online later. Now, if you clustered that file share, we would have failover. So what that meant was whack Matt share running on one node. You could fail it over to another node for planned downtime, or it would automatically fail over for unplanned downtime. But during that failover period, there would be disconnection. So what we wanted to do with our continually available file server is provide access where, so long as the cluster's running, we will actually provide those names for the cluster, the whack Matt share. And so what we actually do is we will go and push whack Matt share to all of the nodes in the cluster. And it will control access to the traffic on this single CSV disk, meaning that if a client was connecting through node 1 became unavailable, all the client does is get immediately redirected to node 2, and they can continue accessing their data. It will automatically restart file copies, things like that. So we're essentially enabling this distributed access now for file servers.
You'd still need some form of shared storage at the back end.
That's correct, yes. You still need some form of shared storage, so you could use your SMB shares or any of the other traditional cluster storage. So fiber channel over Ethernet, iSCSI, serial attached SCSI.
So what this enhancement to CSV ultimately means is we should see more and more partners, OEMs and so on, storage vendor replication, AV vendors being able to plug in more intelligently and give people a solution. So there was a couple of questions earlier on the chat around Hyper-V Replica and what if you've got storage replication already? Why would you wouldn't really want to use two. What can we do there? And integrating those with CSV2 and some of the tools that our storage vendors partners are bringing to market to integrate and provide failover at their level, with their specific technology, is going to be easier with CSV2.
Absolutely. We have a much better partner story just because we got rid of this limitation where we don't necessarily see everything on the file system stack.
Cool. That's excellent. Right. So moving on to the next bit of clustering. We've talked about host clustering. So connect together lots of physical servers, and in the event of a physical host going down or somebody pulling the power to do the vacuuming, those VMs will automatically fail over to another node in that cluster based on what's available in that cluster and some logic. That's host level availability. We lose a host, things come back online on another host. What about if the guest OS stops responding? Well, we've got some clever technology in clustering that enables us to ensure that if a VM does stop responding, and it might be something you want to elaborate on as well, if a VM does stop responding, we're able to get that virtual machine back up and running quickly.
Yep. Absolutely.
Excellent.
We have service monitoring built in there as well, and we can show some of that in a minute.
Yeah, excellent. And I'm going to talk about specifically the third level of availability. The third level of availability is service level, application level availability. So host fails, VM's restarted elsewhere. Guest freezes up, we'll get that guest back online on the current host or on an alternative host to try and get it up and running again. What about an app? What about an application that's running inside the VM that's virtualized on the cluster? What can we do there? And that's where I want to do a quick demonstration and show you what that looks like. So here we are in the environment again, back on Cluster Manager, and we've got a number of roles available. Okay, so these, if I lost the host, so if I lost currently node 2, if I just pulled the plug, these 4 VMs would restart because of the host level availability. If, for example, demo 3 suddenly froze up inside and stopped responding to communication from the cluster and the tools we've got to check whether it's up and running properly or not, then we'd start to restart that VM and get it back up and running again. But I'm talking about the next level of granularity now, looking at the app. And I've gone into demo 6 as an example, and I've looked at more actions, configure monitoring. You notice it's got a very similar logo to that of Ops Manager with that little kind of graph and the up and down. It's not connected with Ops Manager, this particular feature that I'm talking about. So just put that to the back of the mind if that's what you were thinking initially. But I can click Configure Monitoring, and providing I've set up the relevant firewall ports and stuff so I can see in appropriately.
And we need the integration components as well.
Correct, the integration components. I can see some of the services that are running, and this prerequisite link helps me understand what I need to enable to be able to see these. But these are services that are running inside the VM. So Worldwide Publishing Service, IIS, Windows Installer Service, Virtual Disk Service. These are local to the operating system that's inside this virtual machine. And I've ticked that mission critical. It has to be the most mission critical service within Windows, Print Spooler, as our kind of targeted service that we want to fail, shall we say, gracefully.
Hey, there's some printing shops out there that would hate the sarcasm. They always need their printers online.
I've dug myself a hole there. I'm not going to be able to dig out of it, but there we go. Mission critical. Here we go. So this particular VM, I'm inside the VM now. I'm looking inside demo 6, and let's look at the print spooler properties for those important print spoolers. And we'll look here, and we'll see recovery. These are just natural Windows settings. I've not tweaked these, changed these. First failure, if I stop that service, it's going to restart it. If I stop it again abruptly, it's going to restart it. Third failure, it's going to do nothing, and that's where clustering is going to kick in. So let me come out of there, and let me kill Print Spooler. Sorry if that offends anybody out there. Oh, hang on. Could not be terminated. Access is denied. Right, let me run as admin. Now you see another demo where I need to run as admin. Killing a service is an administrative task. I should have known that earlier. So there we go. Let's bring this down and let's try it again. And all good admins have it copied and pasted. Right, terminated. So it's gone off. It should start running again. You see, it went off briefly and then came back. We'll do it again. We'll refresh over here. It's gone. I'm refreshing. It's back on again. So that's 2. That's what Windows would have done as a guest or as an OS in general, physical or virtualized. But in this case, I'm going to kill it again. Poor print spooler. And I'm pressing F5.
Not coming back, right?
Not coming back, I'm afraid. Not coming back. Let's pop out of this particular VM. Let's go back to the cluster. Now, this is going to take a minute or two. I say it's going to take a minute or two. I was being pessimistic there. I should have known it was going to be so quick. There's information here. The operation did not complete on resource virtual machine. And there's a bit more that's off the screen there that we can probably see if we mouse over. But down here, application in VM critical. So an event has been logged. You'll see at the cluster event level here, it's not looking all happy anymore. There's a little event. If I look at cluster events, no events found. There's one event. There we go. Resource Control Manager, cluster resource virtual machine is in clustered role, has received a critical state notification. So it's basically telling us that that app, that service within that VM has encountered a problem. Now, I've turned off functionality in Cluster Manager that would normally restart that VM on the whole. So it would actually restart the VM and get it going again. The reason I've turned that off is because you might not want the VM automatically restarting if there's an error. You might want to just simply track the event that's now been raised through something like Ops Manager and then perform some remediation yourself. But in this case, I've found that this particular service within Windows has stopped, and I'm able, if I wanted to turn that feature back on and remediate that automatically. But you'll see that the functionality, the integration we've built with services right from outside the cluster inside the guest operating system as well. If I look at settings, I can probably see where I can make that change, actually. But yeah, powerful feature. I'll look for it later. Powerful feature that's enabling us to provide organizations of all shapes and sizes with visibility into what's going on inside their workloads and their infrastructure. So, next bit around maintenance. We've seen that we can keep things up and running. What happens if we need to patch? Patching clusters, if you're using tools like System Center Configuration Manager, whilst it'll push out patches centrally, it won't necessarily be aware that it's patching a cluster. So when it wants to reboot all of these physical server nodes, these cluster nodes, it's not going to say, OK, we'll do one first and then wait till that one's back online and then do another. It's going to push it out, and if you've configured automatically reboot at 3 a.m., it's going to do the whole cluster at 3 a.m., which isn't going to be a great situation from a cluster where we need at least some of them online to keep our workloads all up and so we can move things around appropriately. Clusterware updating aims to bring, as the name suggests, an awareness to patching a cluster that's simplified, really intuitive interface. So let me go into this and show you what this looks like very briefly. I want to give Simon some time so he can do his final demonstrations. We'll go to Clusterware updating. Very jazzy UI, very simple. I'm going to connect to a cluster. Here's one I made earlier. That's my cluster that you've seen before. Last time this particular process ran was the 15th, which is what, about 15 days ago or so. It ran at 2 in the morning, conveniently. I wasn't up. I wasn't administering my cluster at that point in time. But what it did, it would have scanned. So all this clusterware updating is doing, and there's more to it than this, but what it's fundamentally doing is triggering on each of the nodes a Windows Update check against your WSUS infrastructure or your patching infrastructure. So it's telling those nodes, just do a check. See what updates have been approved for each of the nodes for Windows Update. And then if there have been approved updates made available, we'll run through an orchestrated process that's going to patch one host, move workloads off, reboot it if necessary, move workloads back, then move on to the next host. So it's doing all of that as part of a process, but from here I can do it so easily. Firstly, I can click Preview, and it's going to show me which updates are going to apply, and I'm going to generate the update list. So it's going to query each node. It's going to provide a list of updates that would be applied if I wanted to run this right now. So have we got any more for any more? So node 2, node 4. So waiting on node 3, hopefully. But you'll see it's already brought down one particular update. So there's an update for Windows Server 2012 available that I probably could push out. Once it's queried all of those and got that preview list, I'm going to cancel out of there because I'm not sure what it's doing, I could apply the updates to this cluster. And it's going to take me through a wizard. Remember, this is manual here. This is me manually doing it. I've previewed. It's given me these updates as available. and I'm going to apply them now and maybe at a certain time, or I've got a set of options that I can tweak. So maybe I want to run some pre-update scripts or some post. Do I want a timeout on the reboot? Is there any particular order I want to go at a certain time? I can configure all of these. That's just the default. Recommended updates or not. Confirm, and then bang, update. It's going to trigger a Windows update, it's going to patch those hosts, and it's going to orchestrate all of the VMs and services on top of that cluster to move around. If this was a virtualized cluster, I could use the same kind of approach. Now, if I want to see what's been run in the past, I can generate a quick report. So we'll see what was from December to January. We'll generate a report. The last run was on the 15th, as we saw. Let's make this full screen, make it a bit easier on the eye. And you'll see that Hyper-V, in terms of updates, this update, security update for .NET Framework 4.5 was applied to 2, 3, and 4. A different update, 2, 3, and 4. So it was quite a busy update day. But providing they're approved in WSUS or your patching tool, all cluster-aware updating is triggering the orchestration of apply those patches, move workloads off, balance and move things around. So when you reboot the hosts individually, of which it takes care of, there's no workloads running on there. So there's no downtime to the workloads on the cluster. Really powerful, but really easy as well. Okay, that's the key thing.
I think just to add, the cluster-aware updating is workload specific. So for virtual machines, we're going to do live migration to avoid downtime. But then for other roles, we can patch it. If it's a cluster, we can patch it. So you can patch your SQL clusters, your file server clusters, any other type of cluster which is running Windows Server 2012, we can manage, we can patch.
Yep, so it integrates with WSUS and the application client. It's extensible to a degree, so there is a plugin so that you can harness third-party updates as well. So it's not just about pushing updates down for Windows Server. And what's effectively happening, as we say, is we're moving workloads around so that we can patch and then take a workload offline or a host offline if needed, if the patch requires it, and then move workloads back at a certain time. So it maintains the availability, doesn't impact the cluster quorum, and it just works and integrates with what you've already got in place with things like WSUS. That's all I've got in my environment, a simple WSUS infrastructure. So great for small, medium, and large organizations, because I would not like to be the one who has to patch manually a 64-node, 8,000 VM cluster, because that spells pain for me manually. But with these kind of tools, it makes it much easier.
I mean, at that point, you're almost in a constant state of patching, and we really kind of envision that for these, broad clusters, these private clouds with 64 nodes. Something's going to be patched, but all of this is handled automatically, dynamically, so you as the administrator don't need to worry about this.
Yeah, so from an update perspective, this would compare and contrast quite nicely with Update Manager, which you may be used to in vSphere. Some questions that may have come up earlier when Simon was talking about the clustering is the process seemed like it was still quite a lot of steps. I validated, I did this, I entered IP addresses here, there, and everywhere. Very, very simple to the IT pro to configure, but when compared with VMware HA, which is it's almost like I'll create a new cluster and just click and drag nodes that I'm currently managing into this cluster and it will handle it magically. We can deliver that kind of capability, but it's in System Center. And we'll show and talk about that a bit later on. And Simon will demo how we deploy and integrate clustering from a VMM perspective as well. But it's probably worth just wrapping up the clustering with that prioritization we were talking about before. How can we, in the event of a disaster, make sure that VM1 starts first, VM2 starts second, and you mentioned Affinity as well, so we've kind of covered that, but it might be interesting to show what they look like from an interface perspective in core clustering.
Absolutely. So I'm going to switch over to my demo system now. And while Matt's been talking, I went ahead and I deployed 2 more VMs. So I have VM2, VM3 up and running. Now, what we've done, one of the most requested features was to provide prioritization. And we actually did have this in our last release, but it was binary. It was important or non-important. And you could basically tell the non-important virtual machines do not automatically start. But we realized we needed some better granularity here. So now you can rank your virtual machines as high, medium, or low priority. And what this affects is the startup order and the migration order. So let's say you have a cold start, all of your nodes shut down. Well, you're probably going to want to get your infrastructure servers up first, your infrastructure VMs. So you would assign your domain controllers, DNS, DHCP as the priority 1 servers. Then maybe you have your kind of business critical servers, processing servers, internal applications, development. Get those as a medium priority. So they're up and running once your key infrastructure is up and running. Low priority, kind of assign that to everything else. Use it as you need. And configuring it, as I'm going to show you here, relatively simple. Just click on a property, change the priority. So here we'll change one to high, we'll change one to medium, we'll change one to low. And also, when we do a bulk live migration by placing a node into maintenance, it's going to honor these priorities as well. So what this would mean is, if I say evacuate this node, move everything off, high priority moves first, then medium, then low. And one other feature that's worth mentioning around prioritization, we use a kind of the same best node placement logic as far as figuring out, where these VMs should go. So when you live migrate, it's going to go and move to the best available node. Now, we have a feature that's called preemption. And what this does is it allows high priority virtual machines to always start up, even if a low priority VM is running and taking its resources. So let's say I have a crash, I have failover of my virtual machines. There's not enough capacity to start up all my high priority. We will gracefully shut down the low priority ones, freeing up resources so those high priority ones can start up and you can keep your key critical infrastructure up and running. So that was a relatively short demo there, but this is just basically some of the management that you have here. You also have some additional properties to really configure what nodes should run on which host. Sorry, which VM should run on which host. These are called our preferred owners. So pretty simple to configure in our interface. Just click on the properties of a VM and specify a preferred owner, which is a node which by default that virtual machine should run on. All right, Matt, back to you.
Excellent. So where I want to finish the session and break for lunch so people can grab some food or dinner or whatever the time it is, midnight snack maybe. Just to compare and contrast what we've talked about here from an availability, from a resiliency, a clustering perspective with VMware. And that vSphere hypervisor on its own, if you were to download that free edition, gives you none of that capability, aside from NIC teaming. So yes, I can team and aggregate physical NICs in that ESXi host, but that's it. There's no incremental backup included, that comes with vSphere. There's no replication included with the free ESXi, that comes with vSphere. There's no HA, there's no clustering, it lacks some of the core capabilities to ensure a resilient workload and platform. Hyper-V Server, even the free edition, gives us those capabilities, so it's very, very powerful. When we compare with Enterprise Plus, it does give us more of the capabilities. Cluster-aware updating with Update Manager, keeping VMs apart with Affinity Rules, and prioritizing failover of virtual machines as well. But where it does fall down slightly is it provides an API for that application monitoring that I showed where I failed the print spooler. It gives us that API, but you would still need to buy a partner solution to plug in and give you the similar functionality. We've delivered that base functionality, and we've got the API for partners to plug in as well. So you've got what we'll deliver in the box, and you've got partner solutions that may give more granularity as well. But there's one area that I want to touch on, which is replication, very briefly. What we saw in Hyper-V Replica, we saw the ability we talked about the ability to automate. We showed how we could do things like test failover and configure network settings upon or in advance of failover. The VM replication that is included with vSphere, so not SRM, this is pure VM replication on its own outside of SRM, you can't automate it. The only way you can automate VM replication in vSphere is by buying SRM. What about testing failover? No. What about configuring those network settings in advance? No. So it's lacking some of those granularity bits that you would get with SRM, but is lacking in the pure VM replication as part of vSphere. And there's a couple more items as well, but the key ones around testing, around failing over with those network settings as well. They're really useful to especially small and mid-sized organizations who can take a lot of benefit from having that pre-configuration done, being able to reverse replication back and forth as well, very flexibly. It's a very powerful package, and it gets even more powerful when we wrap System Center around it, as Simon alluded to earlier. Also, that cluster-aware updating. Some of you may know about System Center 2012 Virtual Machine Manager, and it offers that ability to patch clusters and move workloads around. Similar kind of thing, and we'll touch on that later on as well. When we think about sizing, we already talked about cluster size and scalability, huge scale on the Hyper-V side. no clustering on the ESXi or vSphere hypervisor side. vSphere Enterprise Plus gives organizations a pretty big cluster scale, more than enough for most organizations as well. But when we think about guest clustering and the flexibility that we've got now in the platform with virtual fiber channel, network-based iSCSI, and SMB, we've got great solutions to virtualize your clusters, SQL clusters, other clusters that may be for different workloads, Windows Server clusters in general. Whereas vSphere is a little bit different around, well, fiber channel support is capped at 5 nodes according to some of the VMware documentation that's referenced at the bottom there. SMB storage, do they support SMB storage? It doesn't explicitly call that out. And when it comes to guest clusters running Windows Server on those vSphere hosts, you can use iSCSI storage and pass that through to the guest directly. However, Windows Server 2012 is not officially supported by Microsoft at this time on vSphere 5.1 because vSphere 5.1 hasn't gone through our server virtualization validation program at this time, which means whilst you can run it, it's compatible with the latest version, it wouldn't be supported by Microsoft at that time. vSphere 5 Update 1, that's different from 5.1, has gone through the server virtualization validation program, so that would be supported with 2012, providing you've got the Update 1 and the relevant hotfixes available. But the final area is agility. Being able to create a guest cluster is all well and good. We've got a physical cluster, virtualized, virtual machines running a guest cluster on there as well. What if I need to use dynamic memory with the virtual guest cluster? I can do that with Hyper-V. So I'm not sacrificing density when I'm running my guest cluster on my host cluster. What about moving individual VM nodes around? So moving one node of a 2-node guest cluster, I want to move it somewhere else in the physical infrastructure. I can do that with Hyper-V. Live migration and dynamic memory for agility and density are supported by Microsoft. But with VMware, there's no support for clustering guests and moving and using memory over commit as well. So you can cluster, but the support statements say that vMotion and dynamic memory isn't supported for VMs that are part of a guest cluster, at least today, vMotion and storage vMotion. So something to be aware of. Flexibility is top of the list for Hyper-V and clustering capability.
So we have some other key questions, and we were already expecting these questions to come up. So Matt and I are a little psychic. We actually predicted them and wrote them down here. So first question: what about hot add resources? What can we do? Where are our limitations?
We talked about this before and showed the hot add of storage. So I added a disk to a running virtual machine, and we hot added memory. It's not called hot add of memory in Hyper-V. There's no tab that says hot add memory. You just adjust the dynamic memory settings by increasing them on the fly, so hot adding memory on the fly. Now vSphere does have a couple more capabilities around hot add, so things like CPU, OS dependent, and you can hot add memory also within vSphere as well, in addition to a couple of extra hot add of NICs and a couple of PCI devices as well. So they've got a bit more flexibility there. We'll be first to hold the hands up, but we think we've delivered in Hyper-V in 2012 what the customers are looking for from a core perspective. And whilst hot add is great, hot remove is sometimes equally important. And I can hot add a CPU on vSphere, but until I reboot that machine or turn it off, I can't get that CPU back out, which could become important in chargeback type models where you want an extra CPU for a period of time.
So the next question we get asked a lot is, what about fault tolerance? Now, VMware has a feature, VMFT, fault tolerance, where you can essentially run two VMs in lockstep. Now, we, as an engineering team, the cluster team sat down and we thought about, do we really want to add fault tolerance? And as we kind of looked to the huge list of limitations around it, we decided to invest our engineering efforts on other technologies. So we have no in-box fault tolerance. There are some third-party solutions that can kind of get us there. And really, when you think about fault tolerance, what you're trying to do is offer real-time protection, have zero downtime for mission-critical systems. But if you think of the limitations, when you virtualize, your goal is to consolidate. With fault tolerance, it limits the number of virtual machines you can place on a host to just a few, so it kind of kills the consolidation. But then don't forget, you're doubling that up on your fault-tolerant pair. So you've really reduced consolidation by a significant amount. Additionally, there's pretty good redundancy that you already have throughout your hardware, right? You have NIC Teaming, you have multi-path I/O for your storage. So really, all fault tolerance can protect against is the failure of a non-redundant part, so maybe a motherboard. Now, you've also got to consider, though, when you're running these two guest operating systems in lockstep, you have a blue screen on one of them, guess what? You have a blue screen on that other. So you're not actually protecting anything within the guest itself. So when you kind of evaluate, hey, I got to run a mission-critical workload. Oh, I also forgot to mention CPU limitations. Right now, you can't really run any high-end workloads due to CPU limitations. So when you've got to run a low-power workload that's mission-critical, it's not you already have hardware resiliency, it doesn't protect against blue screens, there's really almost no applications that this has a significant amount of benefit for. Now, I did actually find one customer, and I ask this all the time, do you really need fault tolerance, or is it just kind of a nice to have? Would regular failover be fine? One customer said yes, they need fault tolerance. They have a mission-critical system. And I asked, well, hey, give me details. What is it? And it was a government organization, so I got an answer. If we told you, we'd have to kill you. And they weren't joking. There wasn't any humor in it. So there are some applications, but apparently, hey, you got to be really special. You got to be on one of those government whitelists. I'm probably not on one of those. And so, hey, maybe it works for you, but generally, we decided not to invest engineering in fault tolerance due to all the limitations it has and really the practical gain you can get from it.
But there's a couple more questions to wrap up, which we expect to come out. What about DRS on the VMware side? Where's the Microsoft equivalent for that? And DRS on the VMware side helps to balance, at a high level, helps to balance virtual machines across a clustered environment. So if certain VMs are getting heavy and certain hosts are getting light, we can move VMs around to provide the optimal resource at a certain point in time. And power management takes that one step further by saying, okay, at a weekend or at a certain point in time, if we can realistically consolidate our 100 VMs onto 4 hosts instead of the 6 that they're running on currently, maybe we can move them onto the 4 and then power down those remaining 2, and if we need them, we can bring them back online. Those kind of things, those kind of features, along with things like backup and data protection at a more centralized level, and host profiles, so configuring hosts and deploying them out, we'll touch on in the System Center section later on. And Simon's going to do some demos, I'm going to do some demos as well. So with that, we've gone through 4 key areas. We've looked at scale, performance, density, multi-tenancy security, flexibility, HA, resiliency, clustering. We've covered a whole load of Windows Server stuff, compared it and contrasted it with the vSphere Hypervisor and vSphere Enterprise Plus. But there's still more work to do when we talk about management. But hopefully that's given you a flavor of where we're at in terms of pure virtualization, Hyper-V Server, Windows Server, Hyper-V as well. Lots of useful resources, Technet Eval Center, IT camps. Make sure you sign up for MVA. There's more technical readiness, more depth on specific areas you'll be able to find online as well. And all of the PowerShell scripts and stuff we've run in here are also documented on Technet.
Great, thanks, Matt. So now we're going to take a 30-minute break. You can find out what time we're going to be restarting by taking a look at the Schedule tab, which is on your navigation pane. But make sure that you refresh that first so that you get the updated schedule. After that, as Matt said, we're going to come back and we're going to jump into our cloud capabilities. So we will see you shortly in approximately 30 minutes. Thanks.